And once again, we'll share this important message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Today, we are going to answer your questions from 6.7 from yesterday, and then go on to 6.8 and also assign the chapter review. Tomorrow, we'll be reviewing for a test coming up on Friday. So there you go. Questions from section 6.7 from yesterday. Anything you want to look at?
I'm okay.
All right.
So I don't need any.
Gregory, how about you? Any questions? From 6.7? Nope, we're good. Oh, still connecting there. We good to go on to 6.8? All right, then here we go. So, 6.8. I want to review some formulas. First of all, the area of a rectangle equals the length times the width. Any questions about that? Okay. Second of all, the area of a triangle is 1/2 the base times the height. Any questions about that? All right. Thirdly, I want to look at something called the Pythagorean theorem. You may have learned about this before, but if not, here we go. If we have, a right triangle, that's a sad looking triangle if I do say so myself, that is a triangle with one right angle. A right angle, the two sides are perpendicular or they meet at 90 degrees, okay? If we have a right triangle, the long side is called the hypotenuse, and it's also called side C. The two other sides are called the legs, and they are labeled A and B. For a right triangle, the following relationship is true. A squared plus B squared equals C squared. So the length of side A squared plus the length of side B squared equals the length of side C squared. Now, again, C must always be the hypotenuse or the longest side, the side across from the right angle. A and B, it doesn't matter which one's A or which one's B because addition's commutative. The two legs can be in either order, okay? So this is called the Pythagorean theorem, named after a gentleman named Pythagoras, who is credited with, I believe, discovering this property or theorem or whatever you want to call it. All right, so now let's proceed. Let's take a look at a problem. These are problems I'm taking out of the textbook, but it doesn't matter anyway. It says flags. The length of the flag of Australia is twice as long as the width. Find the dimensions of an Australian flag if its area is 18 square feet. All right, a flag is rectangular in shape, okay? It says the length of a flag of Australia is twice as long as the width. So we've got the length and the width. If we were to call the width X and the length is twice the width, then the length would be 2x. Is everybody okay with where I got the X and the 2x?
Yes.
All right. Find the dimensions of an Australian flag if its area is 18 square feet. Well, the area of a rectangle is a length times the width. We're told that the area is 18 square feet and area is length times width. So plugging all the numbers and the variables into the formula, we get that equation. Simplifying it further, we get 18 equals 2x squared. I see that this is a second degree equation. So I'd like to put it in standard form, set equal to 0. My leading term is going to be the 2x squared, and it's got a positive coefficient on the right, so I'm going to leave it there and subtract 18 from both sides of the equation. So now I've got 0 on one side equals everything else on the other side. Okay? Well, let's see. On the right side of the equation, I could take out the greatest common factor, which is a 2. I could factor further the x squared minus 9 into x plus 3 times x minus 3. So now I have the equation set equal to 0 and completely factored. Now, something has come up that I kept hoping would just automatically come up before, but it didn't, and let me talk about this. This is what I've been saying at the next step. I would say, take each factor that contains a variable and set it equal to 0. Well, we have this factor of a 2. That does not contain a variable. What you don't want to do is say, well, 2 equals 0. 2 does not equal 0. 2 equals 2. So then the question is, what do we do with the 2? Do we just ignore it or what? Well, we can ignore it in the next step, and here, let me explain why. If I wanted to, I could divide both sides by 2, and I would end up with this, correct? 0 divided by 2 is still 0. So in fact, going back to my original factored equation, I can take each factor that contains a variable and set it equal to 0 and solve it. Because I'm solving for this factor and I'm solving for that factor. I'm not solving for 2. I know what 2 is. It's 2. Okay? Now, we've got the equation x plus 3 equals 0. Subtract 3 from both sides and we get x equals negative 3. We've got the equation x minus 3 equals 0. Add 3 to both sides and we've got x equals 3. So we've got 2 solutions to our second degree equation. X is negative 3 and x is positive 3. However, let's go back and let's look at the actual problem. We're talking about a rectangle. We're talking about the length and the width of this rectangular flag. I don't know about you, but I don't think that a length or a width can be negative. It may fit the equation, but it doesn't fit the actual problem. We can't have a length of negative 6 and a width of negative 3. So we're going to eliminate that solution because it doesn't fit the actual problem. So I'm going to get x is 3, 2x is 2 times 3 or 6. But wait, I'm still missing the units. And if I go back and read the problem again, it said its area is 18 square feet. So if this is square feet, the length and the width would have to be feet. So what are the dimensions? The width is 3 feet, the length is 6 feet. Again, dimensions are the length and the width. Any questions about this particular problem before we go on? All right. Let's see here. Let's take a look at a problem. It says jeans, not as in your chromosomes jeans, but as in blue jeans that you wear. The height of the triangular shaped logo on a pair of jeans is 1 centimeter less than the length of its base. If the area of the logo is 15 square centimeters, find the length of the base and the height. All right, so we've got this triangular shaped logo, okay? It says the height, so we're going to talk about the height, okay? So that's the height, is 1 centimeter less than the length of its base. All right, so this dotted line here is the height, and this distance along the bottom here is the base. Okay, so this is the height, this dotted line, and this is the base. All right. It says the height is 1 centimeter less than the length of the base. So if we call the base x, the height would be x minus 1, as in minus 1 centimeter. All right. Let me read all that again. The height of a triangular shaped logo on a pair of jeans is 1 centimeter less than the base. If the area of the logo is 15 square centimeters, find the length of the base and the height. All right, we're dealing with a triangle and we're given the area. The formula is area is 1/2 the base times the height, as we talked about a little bit earlier. We're told that the area is 15 square centimeters. We're told that the base is x and the height is x minus 1. Okay, so we've got 15 equals 1/2 x times x minus 1. Any questions so far? All right, now I could distribute the 1/2 x to the x minus 1 first, and there's nothing wrong with that. But I'd kind of like to get rid of that fraction, that 1/2, and I could do that first. So what I'm going to do, I'm going to multiply both sides of this equation by 2, being the least common denominator. So now on the left, I get 30. On the right, I get 2 times 1/2, which is 1. Okay, and 1 times x minus 1 is x times x minus 1 is x squared minus x. So now my equation is that with nice whole numbers or integer coefficients. Any questions about what I did there? All right, this is a second degree equation. My leading term is going to be x squared. It's got a positive coefficient on the right, so I'm going to leave it there. And I'm going to move everything over to the right. So I get 0 equals x squared minus x minus 30. So now we've got our second degree equation in standard form. I'm going to rewrite that up here where I have a little more room to work. And what I have there is a trinomial in standard form. It has no greatest common factor. It is not a perfect square. It has a leading coefficient of a 1. Let's see, I need a product that's negative 30 and a sum that's negative 1. How about negative 6 and 5? Okay. So now I'm going to take each factor that contains a variable and set it equal to 0 and solve it. So x minus 6 equals 0. We'll add 6 to both sides. X equals 6. X plus 5 equals 0. We'll subtract 5 from both sides. X equals negative 5. So x is 6. X is negative 5. Once again, those are both solutions to the equation, but we can't have a negative height or a negative base. So we'll eliminate that possibility. So if x is 6, the base is 6, the height would be 6 minus 1, which is 5. But let's see, what units? The area was square centimeters, so the base would be 6 centimeters and the height would be 5 centimeters. Okay, so the base is 6 centimeters, the height is 5 centimeters. Any questions about that example? All right, we'll go on then. Let's take a look at another example. This one is about a sailboat. And we have a triangular shaped sail. So let's see here if I can draw that. So here's our sail, and it has a right angle. This is called the foot of the sail, and this is called the loof. L-U-F-F. That's not a very, let's see if I can fix that a little bit better. Nope, can't do that. There we go. It's called the loof. So the foot is like the base of the triangle, and the loof is like the height of the triangle, okay? It says, the length of the loof is 3 times longer than the length of the foot. So if the foot is X, the loof would be 3X. The loof is 3 times as long as the foot. We okay with that? And let's see. In the picture that you can't see, it tells us that the area is 24 square feet. Okay? It says find the length of the foot and the length of the loof. All right. So the area of a triangle is 1/2 the base times the height. We're told that the area is 24 square feet. The base is X and the height is 3X. Okay. Now, once again, I have a fraction. So let's get rid of the fraction. We're going to multiply both sides by 2. So on the left side, I get 48. On the right side, 2 times 1/2 is 1 times X times 3X, which is 3X squared. So 48 equals 3X squared. I have a second degree equation. My leading coefficient on the right is positive, so I'm going to subtract 48 from both sides and get 0 equals 3X squared minus 48. I'm going to factor out a 3 and get X squared minus 16. I'm going to factor the difference of 2 squares, X plus 4, X minus 4. Again, I can ignore the 3, or I can divide both sides by it, and I end up with X plus 4 equals 0 and X minus 4 equals 0. If X plus 4 equals 0, subtracting 4 from both sides, I get X is -4. If X minus 4 is 0, I add 4 to both sides and get X equals +4. Once again, we're looking for lengths or widths or distances. So X can't be negative. The foot is going to be X or 4. The loof is 3X or 12. And we're talking square feet. So that means that is the area with square feet. So the foot and the loof would both be feet. So the loof is 12 feet. The foot is 4 feet. Now, I want to warn you of something. This happened. A student did this on a test a number of years ago, but I'll never forget it. So in these particular story problems or application problems we've been looking at, we're dealing with length or distance or width, and we can't have a negative length or width. We also can't have a negative time. Some of you maybe are having a negative time, but that's not what I'm talking about. Time can't be negative, okay? But what this student did is they went through and they took their whole test. And the last problem was a problem like this. And they realized that, oh, for this problem, they couldn't have a negative answer. Well, they went back to all the previous problems where they'd solved equations by factoring and everything, and they crossed out all the negative solutions, which was a mistake. In the context of this problem, or these couple ones we've done before, where we're dealing with a length or a width or an area, in that case, we can't have a negative answer. But if all we're doing is taking an equation and solving it, and it's not being applied to some other situation, negative answers can happen. In fact, so just be careful with that, all right? Okay, we've looked at examples of a rectangle and of a triangle where we're finding the area. Now we're going to look at some examples where we're trying to find the length of the side or sides of a given triangle. So this is where we'll use the Pythagorean theorem. Let's see here. Okay. I'm going to make an attempt to draw this picture. We'll see what happens. Okay. So we've got, this is supposed to be the dirt, and we've got this tree, and the tree broke in the wind. Now you can see why I'm not the art teacher. Okay, so let's see, where did that go right here? So what's going on there is there's actually a right triangle being formed. So we had this tree, storm came along and snapped it off. Okay, part of its trunk is still there, and the tree fell, forming a right triangle. All right, so there's the picture. Now, it says a tree was blown over in a windstorm. Find X, then find the height of the tree when it was standing upright. They tell us that this distance is X feet. This distance along the ground is X plus 2 feet. And the length of the tree that fell is X plus 4 feet. All right. So we have a right triangle. We have 3 sides of a right triangle. And we're trying to find the length of each. Basically, it said find X. And then from there, we can figure out how tall the tree was originally. Okay. So we're going to use the formula a squared plus b squared equals c squared. The hypotenuse, the long side of this right triangle, is up here. So I'm going to call that C. The 2 legs, I'm going to call this A and B. Any questions before I go on? Okay. You're probably all wondering why I'm looking over here. It's because I moved my screen picture of everybody to the left so it wasn't in the middle of all the writing. Hopefully it's not. I don't know if it makes any difference. But anyway, okay. So A is X, so we've got X squared plus B, which is X plus 2 squared, equals C, which is X plus 4 squared. Any questions? All right. So now I've got X squared plus X plus 2 times X plus 2 equals X plus 4 times X plus 4, right? Keep in mind, X plus 2, the quantity squared, is not X squared plus 2 squared. Don't make that mistake. We've got to FOIL it out. So we get X squared plus X squared plus 2X plus 2X plus 4 equals X squared plus 4X plus 4X plus 16. Any questions? All right. Simplifying on the left side, combining like terms, I get 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. Now, I have a second degree equation. My leading term is going to be something x squared. I have 2x squared on the left and 1x squared on the right. If I move everything over to the left, my leading coefficient on the x squared will be a positive 1. If I move everything to the right, it'll be a negative 1. And I'd like it to be positive, so I'm going to move everything over to the left side of the equation. So I'm going to subtract x squared from both sides. I'm going to subtract 8x from both sides. And I'm going to subtract 16 from both sides. So 2x squared minus x squared is x squared. 4x minus 8x is minus 4x. And 4 minus 16 is minus 12. And on the right, everything should cancel out. I get 0. So now I've got my second degree equation in standard form. There's no greatest common factor. The leading coefficient is a 1. It's not a perfect square. So I'm going to pull it apart like this. and the product is negative 12. The sum is negative 4. So how about negative 6 and 2? So I get x minus 6, x plus 2 equals 0. Any questions? All right. So x minus 6 equals 0 and x plus 2 equals 0. If x minus 6 equals 0, we add 6 to both sides and we get x equals 6. If x plus 2 equals 0, we subtract 2 from both sides and get x equals negative 2. Once again, x is a distance. Once again, we're going to eliminate the negative answer. Let's see. And we're talking about feet here. So if x is 6, this would be 6 feet. This x plus 2 would be 6 plus 2, so this would be 8 feet. And x plus 4, 6 plus 4, this would be 10 feet. Now, we found x. X was 6 feet. But let's go back and look. This is what it says. It says, find the height of the tree when it was standing upright. We don't want to add up all 3 sides. We need what? The piece of the trunk still standing, and then the piece of the tree that was broken. So we've got 6 feet plus 10 feet. So the total is 16 feet tall. All right, so the tree was 16 feet tall before 10 feet of it broke off. Any questions? Okie doke. We'll go on to another problem. Let's see here. All right, this says Moto X. We've got a skateboarder, and let's see here. There's this ramp, and it comes up like that. And then there's this landing ramp. And okay, that's supposed to be, maybe I should use my straight edge here to make this a little bit more respectable. Not much, but a little. Maybe I'm just making it worse. All right, so we've got this skateboarder. Let's see, skateboarder. And he's up here. Here he is, that's my lovely skateboarder. And he's going to land on this ramp. And so the thing on the left is the takeoff ramp. The thing on the right is the landing ramp. And they tell us that this distance is x. This distance is 17 feet. And this distance is 15 feet. This is a right angle right there. Okay. And they want us to find the height of the landing ramp. So basically find x. So again, we're dealing with 3 sides of a right triangle, not the area, but the length of each side. So we're going to use a squared plus b squared equals c squared. And which is the longest side, the x, the 15, or the 17?
17?
Good. I'm sorry, everybody had fallen asleep. No, I'm just kidding. So this is C, and we'll call X A and 15 B. Okay, so we've got x squared plus 15 squared equals 17 squared. All right with that? Which gives us x squared plus, I believe that 15 squared is 225. And I believe that 17 squared is 289, but I'm going to check that just in case. Oh, yep, I'm right. Okay. Any questions so far? So I've got a second degree equation. So I want to set everything equal to 0. So I'm going to subtract 289 from both sides. Let's see, 225 minus 289 is minus 64. I've got the difference of 2 squares, x plus 8, x minus 8 equals 0, x plus 8 equals 0, x minus 8 equals 0. If x plus 8 equals 0, x equals negative 8. If x minus 8 equals 0, x equals positive 8. Once again, we're dealing with a distance or a length, so it can't be negative. So x is going to be 8. And what are the units? Feet. And the question again said, find x, the height of the landing ramp. So the answer is 8 feet. All righty with that? Okay, let's take a look at another one. How are we doing? Oh yeah, we got time. We got all kinds of time here. Okay, let's see here. This is a boating ramp. And so there's this picture. And I just, I have to show off my artistic talents or lack thereof. So here's the water. And then there's this red pickup truck up here. I'm probably not going to win any awards for my drawings. And then there's this boat. And lovely looking boat. Okay. And none of that really matters. What matters is that right here, we've got the right triangle that's here and here. It's just that I don't want you to miss out on the pictures. And then there. Okay? That's supposed to be a straight line there. All right. So we've got this. Let's see, it says the inclined ramp of the boat launch shown in the next column, which is here, is 8 meters longer than the rise of the ramp. Okay, the run is 7 meters longer than the rise. How long are the 3 sides of the ramp? So let's see here. The inclined ramp is that top piece, okay? So again, we've got 3 sides. It says the inclined ramp is 8 meters longer than the rise. And then it says the run is 7 meters longer than the rise. So can you see that the inclined ramp is being compared to the rise and the run is being compared to the rise? So if we make the rise x, the inclined ramp is 8 meters longer. So this is going to be x plus 8. And the run is going to be 7 meters longer. That's going to be x plus 7. So basically, we've got a triangle with the length of the 3 sides, x, x plus 7, and x plus 8. Okay? Now, x plus 8 is going to be the hypotenuse. So that'll be c. We'll take the rise as a and the run as b. And again, a and b could be switched. It wouldn't matter. Using the Pythagorean theorem, a squared plus b squared equals c squared, we get x squared plus x plus 7 squared equals x plus 8, the quantity squared. And now it's going to be very much like a problem we did a little bit ago. I'm going to have x squared plus x plus 7 times x plus 7 equals x plus 8 times x plus 8. Foiling everything together, I get x squared plus x squared plus 7x plus 7x plus 49 equals x squared plus 8x plus 8x plus 64. Any questions? All right, simplifying the left side, I get 2x squared plus 14x plus 49 equals x squared plus 16x plus 64. Once again, to have a positive coefficient, I'm going to move everything to the left side of the equation. So I'm going to subtract x squared from both sides, subtract 16x from both sides, and subtract 64 from both sides. We pause briefly for station identification. This is the Mayo's Math Network. All right, 2x squared minus x squared is x squared. 14x minus 16x is minus 2x. And 49 minus 64, what is that, 15? Minus 15, is that right? 49, 59, yep, equals 0. So once again, we've got a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square, and it has a leading coefficient of a 1. So the product has to be negative 15. The sum is negative 2, negative 5, and positive 3 are your two numbers. So x minus 5 equals 0, and x plus 3 equals 0. Adding 5 to both sides, x is 5. Subtracting 3 from both sides, x is negative 3. The question said, find the length of each side of the ramp. It can't be a negative distance, so that one goes. So if x is 5, the rise is 5, let's see, what units? Everything was in, let's see here, meters. It said one was 8 meters longer, so this is going to be 5 meters. This is going to be 5 plus 7 is 12 meters. 5 plus 8 is 13 meters. So the rise is 5 meters, the run is 12 meters, and the inclined ramp is 13 meters. I didn't mention this earlier, but a quick way we could check this, if this is true, then 5 squared plus 12 squared should equal 13 squared. 25 plus 144 equals 169. 169 equals 169. So it checks. And there you have it. All righty. So you should add to your arsenal of formulas. Let's see, where was it? Back here. You should definitely know the area of a rectangle is length times width. You should also know the area of a triangle is 1/2 the base times the height. And you should also know that for a right triangle, a squared plus b squared equals c squared, where a and b are the two shorter sides or the legs, and c is the hypotenuse or the longest side. Any questions?
You said you were going to go over review questions. Is that going to be today or tomorrow?
That's going to be tomorrow. So you do 6.8 and the chapter review in WebAssign, okay? And then tomorrow during class, I will answer questions that you have from 6.8 in the review. And then Friday, there's no class meeting. You just take your test.
Okay.
All righty.
Another question for our test, is that going to be open notes or no?
No, it's not going to be open notes.
Okay.
In fact, so hang on a second here. I'm going to stop the recording. Well, maybe I should just leave it going. So at the beginning of the quarter, I sent out a email that had 2 attachments. One of them was the course syllabus, and the other one talked about testing procedure. You might.
Yes, I recall.
Okay. So let me just refresh your memory, okay? You're supposed to do your own work. You're not supposed to have any communication with anyone else, no phone calls, no discussion, no looking up things online. You're supposed to do your own work. When you take the test, do your work like on a piece of paper and then put your answers into WebAssign's testing. If the answer is correct, that's great. If the answer is wrong, if you want to email me your work for a given problem that's wrong, don't go back and keep doing it till you get a right answer. Send me the work that you used to arrive at the wrong answer. I will look at it to see if there's some partial credit that I can give you. Okay? So let's say there's 10 questions and you missed 3 of them. Then you could send me the work from those 3, email them to me. When I go through and correct your test, I will look at your work and consider that, and that may pick up some partial credit. Does that answer all your questions about the test?
Yes.
So we don't need to submit the other work, only the work that we get wrong?
Correct.
Okay.
Okay? You can submit it if you want to, but I'm going to assume that you're honest people and that you're doing your own work, but if something's wrong, then I'll look at your work and see if I can figure out what's going on.
Okay, and then I saw that we have an hour and a half on it. How many questions are in it? Is it like a normal homework?
It's like a normal test. Basically, it's like a test that if we had in class, you'd have 50 minutes. But and when I was starting this, I consulted one of my colleagues as to what they did. And they said they give students extra time because they're still getting used to the WebAssign stuff. And, you know, sometimes people will put in what they intend to be the right answer, but they won't do something correct according to WebAssign. So that kind of gives you some more time to work on it. But yeah, it's not like a huge long test. Okay.
Okay, so it's like 27 questions around there.
You know, honestly, I haven't looked at it in a while. I don't
Okay.
remember off the top of my head. But it's not a huge amount of questions.
Okay.
If you know what you're doing, you will have plenty of time.
Yeah, for
If
sure.
you don't know what you're doing, all the time in the world won't be enough. So there you go.
Okay.
All right, I'm going to go ahead and stop the recording.